Okay, hello class. Today is the 29th of October, as you know. So we are going to get started with our next lesson, which is going to be lesson number 20. We just finished up 19 the other day. Now we're going to get started with 20. I'm sure that you might notice as you open up lesson 20, however, it says write down some notes that you're going to be taking as we're going over the exit ticket that you guys had done. But wait a minute. I didn't have you guys do an exit ticket. So how are we going to do those notes? Well, it's quite simple. I'm going to do the exit ticket right now, and then we're going to go over it, and you're going to have to take some notes on what we are doing as we go through it. So first off, our exit ticket reads, Kiara, Giovanni, and Ebony are triplets, and they always argue over who can answer basic math facts the fastest. After completing a few different math fact activities, Kiara, Giovanni, and Ebony record their data, which is shown below. And it actually gives us all three different methods that we've been working with over the past couple of days. Kiara measures hers in an equation, which is n is equal to 5t, where t is going to represent our time in seconds, and m represents the number of math facts completed. Okay. Giovanni over here recorded in a table where we have our seconds and our math facts. In 5 seconds, completed 20 math facts. 10 seconds, 40. 15 seconds, 60. Last, over here, Ebony has created a table, not a table, a graph over here that we're going to be looking at, namely the most important point. We're going to just look at one point because we only really need to look at one point in order to help determine our ratio, which will help us determine our rate. Speaking of, question number 1 here says, what is the math fact completion rate for each student? So for this, they want to know how many facts per second each of the kids can do. Now I'm going to color code this to make it easier. Kiara's going to be red, Giovanni's going to be blue, and Ebony over here is going to be green, just so that it can stay consistent. Now, if you remember correctly, back from yesterday, when we had an equation, you might not think it at the first because we haven't seen many equations, but actually an equation's actually going to give us our rate the easiest. Because when it comes to our equations, the way to get our rate is we're just going to take this number that is being multiplied by our time, and that's our unit rate. And then all we have to do is put our facts per second at the end of that. Getting our rate from our equation is actually going to be, in my personal opinion at least, the easiest of all three of these, because there's really no math involved at all. It's just knowing I need to take that number, and that number is involved in there. When we get to Giovanni, things are a little bit different, because obviously we're in a table. So using this table, we are going to have to, pull a ratio out of it. In order to pull a ratio out of it, we just need to look at one of our columns. And we can get the ratio of 20 math facts to 5 seconds. And we've pulled out our ratio. Now that we have this ratio, what we can do is, as we do with our ratios, is we're going to turn it on its side. And when we turn it on its side, we change our colon here, that is supposed to mean R2, and we're going to change it into a fraction bar. So we're going to have 20 divided by 5, or 20/5, and that is going to equal 4. And I'm going to have to make this into a rate by writing my facts per second. Now I'm running a little bit out of room here, so I'll kind of use this area over here to help me find out all about Ebony. When it comes to Ebony, since she is in a graph, we need to look at one of our points. I've already pointed to the point that we're going to be using because it's our first point. Normally it's going to be our easiest one. Obviously we can't choose this one because 0, 0 is going to be on nearly every single graph when we're talking about our ratios. So we won't really have to be able to use that. But we can use this one. For this one, remember when I'm listing out my coordinate point, I need to list my x value before I list my y value. So for this, my x value is 1, 2. And my y value is going to be, well, this counts by 6, so 6, 12. So my point is going to be at 2, 12. That means that Ebony can finish 12 math facts in 2 seconds. Honestly, I know I started doing green for this, but I actually think that this green is a little hard to see, so I'm going to erase what I have and I'm going to rewrite it all in this nice purple. So Ebony, we have our point here of 212. So that means that she's able to do 12 facts in 2 seconds. Or she has a ratio of 12 to 2. Now with our ratio of 12 to 2, we can do exactly what we did down here. We're going to take our ratio and we're going to turn it on its side. So we're going to have a fraction, 12 halves, which is going to be equal to, obviously, 6. Normally I just write it over there, but now I'm going to write it down here. In order to make that into my rate, I have to say 6 facts per second. So Kiara over here is able to do 5 math facts a second. Giovanni is able to do 4 math facts a second. And Ebony is able to do 6 math facts a second. This is my pen. So 6. That's a 6. So, the question 2 of this is asking, well, who would win the argument? How do you know? Well, the argument is over who's the fastest at completing math facts. Out of these, I have somebody who goes 4 facts a second, 5 facts a second, and 6 facts a second. Obviously, if I look at these, I'm going to think, oh, the person who's going the fastest is the person who can complete the most facts per second. And that's going to be 6. So that means Ebony, because she's fastest. So Ebony is going to be our fastest math factor. So she's going to win that argument. Now, when it comes to notes, the notes that you want to take on this are mainly the how do I use each of these 3 methods in order to find a rate. As we had mentioned with Kiara, for this, the rate is formed using the number in the equation. So whatever number is in that equation That is what we are going to use to form our rate. That is the unit rate, and then we just need to put our facts per second on it in order to make it into a true rate. When it comes to using a table, you are going to use the table to find a ratio. And then when we have the ratio, we just turn our ratio on its side in order to find our unit rate and then create that rate from it. When it comes to using a graph, what we're going to do is use first point to make a ratio. We're going to make a ratio using that first point. And then when we use that first point to make our ratio, then we do exactly what we did over here. Turn it on its side and use that to find the unit rate, and then use that unit rate to create our actual rate. So the main thing that you are going to need in those notes is this, and this. Okay, those are the three main things you're going to need. Step away for 2 seconds so that you can pause the video and copy down those things that I have started. Well, welcome back. You've just unpaused the video. Now, what we can do is we can continue on to our next question. If we continue on to the next question, we're going to look at the actual meat of what's going to make this lesson a lesson. Now, the thing about this lesson is that a lot of it is going to simply be, I guess, review for us. So we're going to just kind of review a lot of things that we've already done in order to help us better understand rates. Now, a lot of this you could probably do on your own, and in fact, you will be doing a chunk of this lesson on your own. I'm going to be doing about the first half. You're going to be doing about the second half on your own, just so that I can sort of get you guys into the rhythm of things. So, to start us off, we're going to be continuing to looking at rates, and we're going to start off with question A, which now you can read in your own book. Mallory is on a budget, and she wants to determine which cereal is going to be a better buy. Now, she finds out that a 10-ounce box of cereal costs $2.79. But there's also a 13-ounce box of that same cereal that's going to cost $3.99. She wants to know, well, which box of cereal should she buy? Well, let's find out. Best way we can do this is by looking over here. We've got a 10-ounce box of cereal that costs $2.79. And then we have a 13-ounce box that costs $3.99. Now, once again, I'm going to color code them because, well, it just keeps me organized. It makes me feel better inside. So with those numbers, I can use these in order to help me create a ratio. Now, keeping in mind, before I even make these ratios and determine which order I want my ratios to be in, I need to think, well, what do I want to find out? There's two options for what I can find out. I can either find out how many ounces per dollar, or I can find out how many dollars per ounce. Me personally, I like my dollars per ounce. I like my dollars per ounce a little bit more than I like my ounces per dollar. So that means that when I'm setting up my ratio, my first number in my ratio has to be my dollars. And the second... I'm just so rudely interrupted. The second number in my ratio is going to have to be my ounces. So, if we go to this first box, we're going to have a ratio of 2.79 to 10. Now, with a ratio of 2.79 to 10, I can do what we did on that last slide when we had a ratio. When we have ratios, what we can do is we can turn it on its side so that we get 2.79 divided by 10. And that's going to help give me my rate. So, if I were to do 2.79 divided by 10, I would get, actually not exactly, I'm going to get approximately 0.28. And I don't want to write to 0.279 because remember, I'm talking about money. And I can't have 3 decimals when it comes to money. I have to stop at 2. So I'm going to round it to 0.28, and that's going to be dollars per ounce. On the other side, I have a second box that I could work with, and that I'm going to use a ratio. Remember, with my ratio, I need to put my dollars first and then my ounces. I'm going to have 3.99 to 13. With that, I can kind of do exactly what I did before. Flip it on its side and change that colon to a fraction bar. And that'll give me 3.99 divided by 13. When I do 3.99 divided by 13, I'm going to get approximately, because again I need to round to the nearest cent, it's going to be approximately 0.31 dollars per ounce, or 31 cents per ounce. But we're going to just leave it in dollars because that's what we started with. But did this question ask us what is the rate of dollars per ounce for both of these boxes? No, that's not what it asked. It asked us which box should she buy? Well, she's on a budget. She wants to spend as little money as possible. So which one is going to give her more ounces per dollar, or which one is going to spend less money per ounce? Well, this one is. This one only costs 28 cents per ounce. That one costs 31 cents per ounce. So, certainly looks like that first box is going to be the one that she wants to buy, not this second box, because that costs too much. Part 2 of this very question is going to ask, what's the difference between the two unit prices? Well, if I want to know the difference means subtraction. So, well, start out with our larger one. And we're just going to subtract our smaller one. That is going to give me a difference of 0.03. And we're going to keep our dollars per ounce. So it's going to be $0.03 per ounce cheaper to buy this one, or it's going to be 3 cents cheaper per ounce. And that might not sound like a lot, and you'd be right. It's not really the biggest. of differences, but it adds up. And she's on a budget, so she needs to limit her spending. It makes sense. With that, we can move on to question B. And question B says that Vivian wants to buy a watermelon. Vivian loves watermelon. Now, you see Kingston Market has 10-pound watermelons for $3.90. But the farmer's market that's right down the street from Kingston's Market, it has a 12-pound watermelon for $4.44. Well, just like Mallory over here with her cereal, Vivian over here wants to know, well, which watermelon should I buy? Which one's the best price for my watermelons? So, we're going to find it out. Similar to up here, how we were dollars per ounce, this time we are going to be dollars per pound. And I'm going to abbreviate pound with LBS, as we do. And I'm going to, once again, color code this. I'm going to go 10 pounds for $3.90. And in red, I'm going to look at my 12 pounds for $4.44. Similarly to above, if I wanted dollars per pound, I need to put my dollars in the front of my ratio. So up first, I'm going to have 3.90 to 10. And would you look at that? I have a ratio. Man, if only I knew what I had to do with this ratio in order to get a rate. But wait, I do, because I've already done it. I've done it these 2 times, and I did it 2 times on the last page. I know exactly what to do. I need to take this and I need to flip it on its side. My ratio colon is going to change it to a fraction bar. And with that I can divide, and I get 0.39, and I need to make sure that I put on my dollars per pound. So the 10-pound watermelons sell for $0.39 per pound, or otherwise known as 39 cents per pound. On the other side of things, however, I'm going to have my other one, which, again, I write my dollars first in my ratio, because I want dollars first and then pounds. So $4.44 to 12 pounds. Same as before. I have a ratio. All I have to do is take that ratio and turn it on its side. So 4.44 divided by 12 is going to equal what? Well, I have 4.44 divided by 12 will give me 0.37, and still going to be in dollars per pound. But again, just like above, it's not asking us what is the rate of dollars per pound for these 2 different markets. No, it's asking us which market has the best price. So, well, let's look at them. Over here, Kingston's Market has their watermelon selling for $0.39 per pound, or 39 cents per pound. Over here, the farmer's market is selling for 37 cents per pound. So, from the looks of things, this one is going to be cheaper. This one is only 37 cents per pound. That one's 39. That's more cents per pound. So this one is going to be a better deal than this one. Now, similar to up above, it's going to ask us what the difference is. Difference still means subtraction, so I'm going to go with my 0.39. I'm going to subtract my 0.37, and in the end that is going to give me 0.02, and it's still going to be in dollars per pound. It's going to be in dollars per pound. So this is going to be $0.02 per pound cheaper, or 2 cents cheaper. Both of those completely valid answers to that. Now, with these 2 questions done, what we can do is we can move on to our next question. For our next question, I'm sure you can notice, we actually skipped the next 2 questions. Well, why did you skip the next 2 questions? Because we quite literally basically already did them. It's just going to be the same as A and B, but do it again with different numbers. That's why I'm going to leave those 2 to you guys to finish. With that, however, we can move on to question E, which is actually a fairly simple question. Question E says that this table below shows the amount of calories that Mike burns as he runs. We have a table with our number of miles ran and our number of calories burned. In 3 miles, he's able to burn. In 3 miles, he was able to burn 360. 6 miles, 720. 9 miles, wait a minute, we don't know what that is, but I guess we're going to have to find it. And in 12 miles, 1,440. Okay, we need to fill in that missing part of the table. There's actually going to be a couple of different ways that we could do this. The first way is likely the way that it intends for us, but I'm going to give us a few sneak peeks of different ways that we can do it. First way is the way that it probably wants us to do it, and that is to take our ratio and use it to find our rate. So we're going to take this and we're going to find a ratio with it. That ratio is going to be 360 to 3. We're going to use that to find our rate, and that's going to be, turn it on its side, 360 divided by 3 is going to be, well, what's 360 divided by 3? It's going to be 120. Well, 120 what? Well, up first I had my calories, second I had my miles, so this is going to be calories per mile. So I know that I burn 120 calories per mile. If I take my 120 calories per mile and I multiply it by my missing value, I have 9. So my 120 calories per mile times 9 miles is going to give me my number of calories. If I were to do 120 times 9, it's going to give me 1,080. So that's what I'm going to put into this slot. Now, as I mentioned, there's actually a couple of different ways that we could do this. Some of which we also already know. The first way is, well, every single time over here I'm going up by 3. Which means that that's changing at the same rate. Which means that this needs to be doing the same thing. This is going up by 360. So then this one also needs to go up by 360. So the question is, well, what's 720 plus 360? Well, wouldn't you know it, it's actually going to be equal to 1,080. I'm going to fix that 0 because it's annoying me. So our second way was doing it by that. Our third way is, well, if I know that I'm going burning 360 calories in 3 miles, what I can actually do, so if I need to find out how it's 9, start with my ratio of 360 to 3, and then multiply this side by 3, and if I multiply my right side by 3 to get 9, guess what I'm going to have to do it to the other side as well. Multiply 360 by 3. Well, what's 360 times 3? That's, strangely enough, going to give us that same number. So there were 3 different ways that we could solve this problem, all of which gave us that same answer of 1080. All of which work just the same. Thought that this question was a little easy. Thought that you guys, it was too much of a gimme. So we went through it together. And this is going to be the last problem that I go through with you guys, I believe. Let me make sure. Boom, blank page. Last question. Last question says that Emilio wants to buy a new motorcycle. And he wants to compare the gas efficiency for each motorcycle before he makes his purchase. The dealership presented the data below. For his sports motorcycle, it's in a table. For the leisure motorcycle, it is in a graph. Well, we went over it in the beginning of the class, how to go through not only these two, but also equations. But we can go through it again. For our sports motorcycle, since it's in a table, what I'm going to have to do is I'm going to have to yoink these two. And I'm going to make a ratio out of it. That ratio is going to be 287.5 to 5. If I want to find out the rate at which it can go in terms of miles per gallon, I have my miles first and I have my gallons second. Well, now that I have a ratio, turn it on its side. 287.5 divided by 5. 287.5 divided by 5. Well, I honestly don't expect any of you to know it off the top of your head. So using a calculator, you can pretty easily find out this is actually going to be 57.9. But 57.5 what? We're going to have to put our rate unit at the end of this in order to make it into a true rate. As I mentioned, we're going to have miles per gallon. So I'm going to write this as miles per gallon. But actually, you know, similar to how we have miles per hour as a shrunken down thing, we normally will shrink down miles per gallon as mpg. So I'm going to use mpg for whenever else I'm writing miles per gallon from now on. Now, well, we found out how efficient the sports motorcycle is. The sports motorcycle gets 57.5 miles per gallon. Every gallon of gas you put into that sports motorcycle, it's going to make sure that you can drive at least 57.5 miles. So, if we want to compare, we need to drop my pen. If we want to compare, we're going to have to look at our leisure motorcycle. And, obviously, as per... The tip of my pen fell out. Where's the tip of my pen? This is where I play my music for technical difficulties if I have it. We'll find out in a second. So, first things first, we need to figure out what this point is. I'm using my mouse right now in case you can't tell. So what this point is, well, first we have 2 and we have 110. Okay, so the point has to be 2, 1, 10. So with our point of 2, 110, we can create a ratio of 110 to 2. We can have this ratio of 110 to 2. Oh, so still follows it. I'm going to need a new pen. This is annoying. It still follows it, but the tip broke off of my pen. I'll have to talk to somebody about that. Now, I've found my ratio. As I did over here, I'm going to need to take this ratio and I'm going to have to put it on its side. So 110 over 2. And that is going to equal, well, this one's a much easier thing to divide than this one over here. 110 divided by 2 is going to give me 55. Ooh. It's going to give me 55. And then we're going to keep that same miles per gallon. Now the question is asking which one is more gas efficient. So we need to think, well, what does gas efficiency mean? Gas efficiency is going to mean which one of these can go the most amount of miles with the least amount of gas. Well, this one can go 55 miles in a single gallon. This one can go 57.5 miles in a single gallon. So that means that this one right here is going to be more efficient. This one over here, ooh, yikes. Writing with a mouse is much less fun. This one over here is going to be less efficient. But it also asks by how much. Well, if I want to find out how much, I need to know the difference between these two. And the difference, obviously, as we've mentioned before, is going to be subtraction. So 57.5 minus 55. And that's going to give me 2. That's a horrible 5. Let me try again. 2.5 miles per gallon. It's going to be 2.5 miles per gallon. So as we can see from what we have up here, sports motorcycle is going to be more efficient, specifically by 2.5 miles per gallon. I really wish I could have kept using this. So with that, we've finished question F. As I mentioned and as I showed, this is actually the last question that we are going to be going over. The rest of this lesson, including the 2 that we skipped, are going to be yours to finish. Now you might say, well, that's a lot. And I might say back, well, a lot of them we've already gone over how to solve. It's just up to you to sort of replace the numbers that we have used with the numbers that you now need to use. We've already gone over the methods to solve all of the problems that are there. It's up to you to know which methods to use and when. If anybody needs help, obviously, I'll be available in the Teams meeting for everyone. But I hope that you all have a wonderful day, and I will talk to you guys again tomorrow. Obviously, we won't see each other, but I'll send a couple of messages through Schoology. Everybody have a great day, and farewell.